Hi friends, this question covers most of the remainder theorems. Initially, use the remainder of sum property where you need to find remainder of 222 raised to the power 555 when divided by 7 and add it to the remainder of 555 raised to the power 222 when divided by 7. Firstly, break the base 222 as a multiple of 7 plus the leftover amount raised to the power 555. When this is divided by 7, all the numbers that include 217 will leave the remainder 0 as it is a multiple of 7 and you will be left with only 5 raised to the power 555. Now find only the remainder when this number is divided by 7. Similarly, here break 555 as 553 plus 2. Again, when we expand this, all the numbers including 553 will leave the remainder 0 when divided by 7. So you need to find remainder when 2 raised to the power 222 is divided by 7. Next, to solve for both of these, we'll use Fermat's theorem, which states that for any prime number p, when a raised to the power p minus 1 is divided by p, the remainder is 1. We know that 7 is a prime number. So for any number 6 power, when divided by 7, will leave the remainder 1. Remember, a should not be a multiple of 7 because in that case the remainder would be 0. Both 5 and 2, none are multiple of 7. Write this as 5 raised to the power 6 into 92 and 5 cube. Similarly, 2 raised to the power 6 into 37. So when divided by 7, 5 raised to the power 6 when divided by 7 leave the remainder 1, and this is 92 times and all of them leave the remainder 1. So by remainder of multiplication property, this will be 1 multiplied by 5 cube divided by 7. Here 2 raised to the power 6 when divided by 7 will leave remainder 1, and 1 is multiplied 37 times, all giving the remainder 1. We get 125 divided by 7, and the remainder we get here is 6. Finally, add 6 and 1. We get 6 plus 1 divided by 7. So 7 divided by 7 finally leaves the remainder 0.